Hi, Graham.
Hi, Graham.
John.
I like
Okay.
John.
So functions can be approximated with Taylor polynomials. Okay. The more terms,
More accurate.
the more accurate. Okay. So we have. Okay. Now, side note: the more terms, the more accurate within the interval of convergence. And we'll talk about what that, well, you guys kind of know what it means. Okay, so this is a power series. Okay, so a power series centered at 0, a power series centered at, in this case, yes, A. Basically, we're taking our polynomials and they're going to be infinite, so we write them as a series. Right? So e to the x is this power series. 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. And if we keep going and going and going and going towards infinity, we have this power series. Okay, so we're just taking our Taylor and Maclaurin polynomials and they're going towards infinity. Okay, now this interval of convergence. Okay, there are 3 things that can happen with a power series. First of all, they're going to converge. Okay? But there's only 3 different ways they can converge. Okay? Which I think you saw these pictures yesterday. They can converge only at the center, C for center. Okay? So that would be just converging at one point. They could converge on an interval, so a little bit on each side of the center, where we have what we call a radius of convergence. You saw that word yesterday when you were reading. Okay, or it can converge along the entire number line. It converges all the time. So it converges at the center, it converges on an interval, it converges everywhere.
Does it always converge at least one of those 3?
Mm-hmm. It will. Okay, you see that R there? That R is called our radius of convergence. Okay, so what we're going to do is we're going to find a radius of convergence so that we can write our interval of convergence. Okay, so there's going to be 2 very different wordings. Find the radius of convergence, find the interval of convergence. Okay, so let's talk about R. R is our radius of convergence. So how far away from the center will we converge? Okay. Now, just because we have a radius of convergence, that doesn't account for the endpoints. That gives us an interval, but then we have to actually check the endpoints. So these are the 6 different things that can happen. We can converge only at C. We can converge everywhere. Or we can converge on an interval with any of those 4 things happening. The endpoints don't converge. One endpoint converges. Both endpoints converge. Which we saw these pictures yesterday. Yes? No? Oh, okay. How do we get to converge at only C? What would our radius of convergence need to be?
0.
0. So if your radius of convergence is 0, you're only converging at the center. How do we get, what would our radius of convergence be if we wanted to converge everywhere? Infinity. Okay? And we're actually going to find the radius of convergence by taking a limit. So you're either going to get a number, 0, or infinity. Those are the only types of limits that we're going to find, right? So here are the two cases for 0 and infinity. And then obviously if we get a finite number, that's our radius to go on each side of the center. Okay. How will we find the radius of convergence? Using the ratio test. Ah, the ratio test. We all love the ratio test, right?
Yeah, some of those exams end up like fraction.
There's like 4 fraction bars in the row, like all in the absolute value, like just all lines.
Yeah.
Yeah. Because I always write mine as
Times
the reciprocal.
to avoid that.
Yeah.
mess of-
Yeah. So we'll do this example, and then hopefully, like, as we work through these problems together, we can like fill in the pieces that you were guessing on yesterday. Okay.
Oh, right, Graham's not giving, I want you to shout ratio test.
You hear that, Graham?
Okay, so let's remember the ratio test. So we need to take 2x to the n plus 1 over n plus 1 squared divided by a sub n, or we're going to multiply by the reciprocal. It makes it look prettier, right?
Yeah.
Okay. Now remember, we're taking a limit as n approaches infinity. X is just there, okay? And I think that may be what was hard yesterday to figure out what the heck to do with X, right? Okay, so let's do this. What is 2x to the n plus 1 divided by 2x to the n? 2x. And then we have times n squared over n plus 1 squared. So what's the limit as n approaches infinity of this? This goes to 1. So we have the absolute value of 2x. Okay? And for the ratio test to work, this limit needs to be less than 1. Okay? Now, that 2 inside the absolute value, it can come out, right? So, x is less than 1, or the absolute value of x is less than 1/2. That is your radius of convergence. Your radius of convergence is 1/2. Okay with that, Alice? Okay, so you are going to get more times than not something with an x as part of your limit. That's good, so you can solve for x, and that's what gives you your radius of convergence. Okay? Okay, so since you guys kind of have an idea of what's going on, do you want me to continue and find the interval of convergence? Or, okay.
Jared has spoken.
So our interval of, or our radius of convergence was 1/2, right?
Yeah.
Okay. Where are we centered? 0. So 0 plus 1/2, 0 minus 1/2. That's our interval. We need to figure out if the endpoints check out or not. And this is where all of your tests you're going to get to use again. So let's imagine x equals negative 1/2.
Oh,
This is alternate series.
Okay, so what's negative 1/2 times 2?
Negative one.
So this becomes negative 1 to the n over n squared.
that makes more sense. What it is.
Does this converge?
Yeah.
Alternating series test. So
We don't actually have to do the tests.
we
Oh, Nathan, what did you do? Because that's just what I wrote on my homework was that's the test. That's what she did, and then
Well, it converges absolutely.
And then do we have to do that?
okay. How about x is 1/2?
Yes.
What's 1/2 times 2?
One.
What's 1 to the n?
One.
So we have 1 over n squared.
P series. So P is greater than one.
So we get to include both of our endpoints.
And then number of numbers that are not.
Okay, so 3 problems in one. 3 things I have to see. Ratio test to find the radius. Check one endpoint, check the other endpoint.
We just keep getting longer.
It will be a 2-day test though, and that is 2 weeks from yesterday. All right, so let's look at this one. Okay, so ratio test. We have 2x to the
2n plus 2.
2n plus 2. Please be careful. When we substitute n plus 1, it gets multiplied by the 2. Over
2n plus 2 factorial.
okay. 2x to the 2n plus 2 over 2x to the 2n. Okay. Let's imagine simplifying 2n factorial over 2n plus 2 factorial. 2n plus 2 times 2n plus 1 times 2n factorials will cancel out. So if we imagine the limit as n approaches infinity, what's going to happen here? This is going to go to 0, and what's 0 times 4x squared? 0.
The line converges at the point.
This means our radius of convergence. Hold on. Let me sort out. Yes. That's what you had me panicking. I was like, wait, this isn't right. Okay. Is this less than 1?
Always.
Always. So our radius is infinity, and our interval of convergence is all real numbers.
It would only converge at the point if there's only one point where it's less than 1.
Well, when your limit is infinity, it only converges at the center.
So like when you take the ratio test, what will you get?
Infinity.
Oh,
Two more things we need to talk about. One example, not centered at 0. It's a beautiful.
Okay, let's do it.
It's the ratio test, they all kind of work out. the same.
X minus 5 over 5 to the n.
What?
I don't know, I was just trying to break it apart. It's a lot of.
Really?
Okay, so first of all, does the -1 to the n plus 1 really affect the ratio test? No, because we're inside the absolute value.
Do we have to write it?
Yeah.
Two curves, two long.
Look, lots of 5s, lots of n's. Okay, so let's organize this. X minus 5 to the n plus 1 over x minus 5. To the n. X minus 5, sorry about that. Times n over n plus 1. And then 5 to the n over 5 to the n plus 1. So, can I do that? Okay. And when n approaches infinity, this goes to 1. So we have the absolute value of x minus 5 over 5. And we want this to be less than 1, which means we want x minus 5, absolute value, to be less than 5. What is our radius of convergence? 5. You should end with x minus c right here. Okay? Stop at x minus c. There is your radius of convergence. So radius is 5. Okay? If our radius is at 5 and our center is 5, what's our interval? So now we get to decide if the endpoints are included or not.
We get to decide that.
Doesn't matter.
I think 0 should be included, because it's civic.
Okay. So we have -1 to the n plus 1. When I plug in 0, we get -5 to the n over n, 5 to the n. Be very careful. -5 to the n. How can we rewrite that? Okay. -1 to the n times 5 to the n. Now, let's talk about what happens. These can cancel, right? And we can combine the -1 to the powers, and they become. And what's true about -1 to the 2n plus 1?
Always.
Always negative. So essentially we have -1 over n. Why? Okay. Or it's a p-series, you put a negative in front of it, it's still going to diverge, right? I mean, however you want to look at it, is it going to converge? Can't really see the dot on the eye. Okay. All right, let's look at x is 10. This would be 5 to the n, correct? Does that converge?
Yeah, those, you betcha.
So we can include that. Now, here's where the fun begins. If you look at any, do you have questions?
No.
Okay, you were squinting like maybe
You
you
told me that
me.
there was a face up there and I was trying to find it.
Productive conversation. Did you get to any of the problems with the derivative and antiderivative?
No,
Those weren't even on the
those
homework.
were not on the homework.
Oh, I didn't get it written up there. Shoot. I added them and didn't get them written up there.
So-
I will
Yeah,
add
we
them.
didn't even,
look
I
at
didn't
it.
even look at these, so like,
She didn't teach it to us.
I read it, and it made less sense than the others.
Okay, so here's the thing. Whatever the radius of convergence is for f, the radius of convergence is for f prime and the antiderivative of that. The endpoints, those aren't consistent as whether they converge or not, but the radius of convergence is consistent. So if you know the radius of convergence for f, you wouldn't have to do the ratio test for the derivative. You wouldn't have to do the ratio test for the antiderivative. Okay?
Is it the same for all derivatives of f? Or just-
Right, if you have a power series f and you find its radius of convergence, then that f's derivative will have the same radius of
Oh, okay.
convergence. Okay? So what do we know about this radius of convergence? You know, it isn't this one that we did?
Yeah.
It is.
1/2.
Okay. So if we call this f, this is when you may be frustrated. Let's talk about f prime. Okay. We're taking the derivative with respect to x. X is being raised to a power.
Power.
So power rule, chain rule.
Okay.
Wait, did the bottom not doing theirs?
We're taking the derivative with respect to x. So any of the n's are treated like constants in a derivative,
Okay.
okay?
Yeah.
Now, here we should be safe. N equals 1 to infinity. Okay? Be careful though, if this starting point, like if this was a 0,
That's right.
then you would have to say this is a 1. So always make sure that this can be plugged in to your power, right? If not, you may have to add 1 to this. But right now we're okay, right? All right, so let's simplify this. This is basically 2 times 2x to the n minus 1 over n.
Yeah.
Okay. So then you can plug in your radius of convergence and test the endpoints for this interval. Do you want to go through that?
It's still centered at 0 though.
It's still centered at 0. It still has a radius of 1/2. It's just going to affect the endpoints and whether they converge or not.
The derivative will always be centered at 0, right?
Your derivative will always be centered at the same place.
Same place?
Uh-huh.
Oh, okay, yeah.
Do you want to test the endpoints?
Sure.
So We know it's gonna be from -1/2 to 1/2, okay? Our endpoints just are going to be affected, so let's talk about x equals -1/2. So this becomes 2 times -1 to the n minus 1, correct?
Yep.
Okay? It's an alternating series, right? With 2 over n. Okay, we can think about this one in our head for right now. Are you okay with that?
Yeah.
That's going to converge by the alternating series test.
Ooh.
Because we've had a little bit more time to work with this one,
Well,
correct?
it's because we don't have to work.
Okay, what's going to be true about this one?
Right.
It's going to diverge because of a p series.
Yeah.
So, how does that compare to our original one?
They both converge.
They both converge, this one, only one of them did. Okay? Let's talk about the antiderivative. Okay, so I'm going to do it up here in green. R equals 1.
Confused, because you said, I'm gonna write it in green and
I used red.
Okay. Antiderivative. What do we do with the power?
Raise it and divide by it.
What else are we going to have to divide by? We're also going to have to divide by that 2 to account for the chain rule. And we have n squared. Right?
Yeah, okay.
Okay.
Plus C.
Yeah.
Technically, yes. Technically, yes.
does that mean we need it? So then we can stop here, because we can see it's already now that constant there.
Okay, so, looking at this and thinking of it in your head, one of the endpoints will create an alternating series. One of them will not.
Yeah.
Okay, but I think this should turn out that both should converge. Yeah. Okay. So I guess you need to add 45 and 47 onto your assignment. I assume you figured out what EOO meant.
Every other
Only
page.
oscillating.
Oscar.
Okay, so this is what I'm going to do. Okay, because some of you have worked on this assignment, and so I'm sure at least all of you need to refine a little bit. If not, do 45 and 47. Okay?
Diagram.
Before we say bitagram, I'm going to give you a quiz to take home.
Take home quiz?
Yes. It will not. No, that is cheating.
Can we study together?
Preferably not.
Yeah.
Now, this will not count as a full quiz, but I still want to see how things are going, okay? I want your input, not one person's input on everybody's paper. Right?
How do we
You want me to forward my answers to Graham? I mean, the paper.
How am I getting this to Graham? I will upload it to my website, Graham.
Great, now he has to watch the video.
That's what we did.
Yeah, I'll type some,
Yeah, he'll probably see the problems for homework and then pause it, and then write them down.
You know what? Yeah. So everybody tuck this away. I want you to be working on at least 45 and 47, if not the numbers previous. Bye, Graham, wherever you are.
Bye, Graham.